there, and welcome to the Sleepy Science Channel. Find yourself a comfortable place. Maybe you're already lying down. Maybe your pillow is soft beneath your head. Maybe the room around you is growing quiet and still. That's perfect. That's exactly where you should be right now. Take one slow breath in and let it out even more slowly. Feel your shoulders settle. Feel the small muscles around your eyes soften just a little. Tonight, we're going to talk about something that almost everyone has seen, but very few people have taken the time to simply sit with and understand. The colors of the sky at sunset. That great, slow transformation that happens every single evening somewhere on this earth, without fail. The way the blue overhead deepens and shifts, the way the horizon catches fire in the gentlest possible sense of that word. Gold, then amber, then a rose so pale it's almost a whisper, then lavender, then the first quiet gray of dusk. It happens every day, and yet it never quite looks the same twice. There's real science behind why the sky does this, and it's the kind of science that feels less like a textbook and more like a secret the earth is gently telling you. If you're willing to sit still long enough to hear it, nothing complicated, nothing demanding, just soft, curious, beautiful fact after beautiful fact, drifting toward you the way colors themselves drift across an evening sky. So settle in, let your breathing slow, and let's begin at the very beginning with light itself. Sunlight, the light that reaches you every day, the light that warms the top of your head and makes windows glow in the morning. That light looks white or pale yellow when you glance at it, but it isn't really one color at all. It's every color layered together so completely that your eyes read them all as one. White light is a kind of harmony, a quiet chorus of colors traveling together at extraordinary speed across the vastness of space, arriving at this small blue world of ours, and then, only then, beginning to separate. The way scientists first began to understand this is a gentle story in itself. In the 1660s, a young man named Isaac Newton sat in a darkened room and let a single thin beam of sunlight enter through a small hole in a curtain. He held a triangular piece of glass, a prism, in the path of that beam, and the light bent. It spread. It fanned out across the far wall in a ribbon of color. Red, orange, yellow, green, blue, indigo, violet. Every color your eye has ever learned to love, hidden inside ordinary daylight, waiting to be coaxed apart. He called it a spectrum, but you might just call it a secret. And the reason those colors separate when light bends, the reason red goes one way and violet goes another, is that each color travels with its own particular rhythm. Light moves in waves, like the most delicate and invisible ripples in water, and each color has a different wavelength. Red light has long, slow, lazy waves. Violet and blue light have short, quick, closely packed waves. Orange and yellow fall somewhere in between, like the middle notes of a lullaby. This difference, this small, beautiful difference in the rhythm of each color, is the reason the sky looks the way it does. It is the reason sunsets exist. Because when light from the sun enters the atmosphere, it doesn't travel through empty space anymore. It travels through air. And air, though it feels like nothing at all when you breathe it in, is actually full of tiny things. Molecules of nitrogen and oxygen, the very substance of every breath you've ever taken. These molecules are extraordinarily small, far too small to see, far too small to feel. But they're there, in their billions, in their trillions, hanging in the invisible ocean of air that wraps this whole planet like a soft blanket. And when light meets those molecules, something happens. The light scatters, not all of it equally. The short, quick waves, the blue and violet light, scatter much more easily than the long, slow red waves. They bounce off those tiny molecules and go spinning off in new directions, filling the whole dome of the sky with their scattered energy. The longer red and orange waves pass through more easily, not quite as willing to be redirected, continuing on their straighter path toward the horizon. This is why the sky above you, on a clear and ordinary afternoon, is blue. It's blue because blue light is scattered in every direction, all across the atmosphere, so that no matter where you look overhead, some blue light is reaching your eyes. The sky isn't a surface, it isn't painted, it's a kind of living light, scattered and rescattered, bouncing gently through miles and miles of air until it finds its way to you. And this is already something worth sitting with for a moment, that the color above you right now, the blue of the daytime sky, is not a thing that's simply there. It's a process. It's constant, invisible, silent motion. It's light dancing through the air, finding its way to your eyes every second of every day. Take a slow breath. Let that settle. If you're finding this peaceful so far, it would mean a lot if you dropped a like on the video. It helps more people find their way here for a good night's rest. Now, blue is the color of the midday sky, but the sky at sunset is something else entirely. And to understand why, you need to think about distance, about how far light has to travel to reach your eyes, and how that distance changes as the day grows long. At noon, the sun is high above you. The light coming from it passes through the atmosphere at a steep, nearly vertical angle. It doesn't have to travel far through the air to reach the ground. A relatively thin slice of atmosphere stands between you and the sun at midday. And so the light passes through it fairly quickly, the blue scattering liberally in all directions and filling your sky with that familiar gentle color. But as the day turns and the sun begins to descend toward the horizon, the angle changes. The sunlight is no longer coming almost straight down. It's arriving at a long, low, slanting angle, passing through a much thicker slice of atmosphere to reach you. Imagine shining a flashlight straight down through a glass of water. It passes through quickly, losing little. Now tilt that flashlight so the beam enters at a shallow angle, crossing through much more water before it emerges. That's what's happening to sunlight near sunset. The path the light must travel through the atmosphere becomes dramatically longer, where at noon that journey might be roughly 10 miles of atmosphere. At sunset, it can be 10 times that, 100 miles or more of air, full of molecules, full of those tiny invisible scatterers. And in that long, long journey, something shifts. The blue light, still scattering, still bouncing, gets scattered so many times, redirected so many times that by the time the light reaches your eyes, most of the blue has been sent off sideways and upward, away from your direct line of sight toward the sun. It's been scattered away, removed gently from the equation. And what's left? The colors that were always there, but less eager to scatter. The oranges, the reds, the warm, slow, long wave colors that have been traveling all this way through 100 miles of air and still, steadily, arriving. They weren't scattered off course. They made it through. And so the sun turns amber, the horizon glows. A whole landscape of warm color blooms across the sky every evening as a simple and inevitable consequence of the way light and air interact, of the way short waves scatter and long waves persist. It isn't magic, but it feels like it. And perhaps that's the most restful kind of wonder, the kind that's rooted in something real. Rest here for a moment. Let the image settle in your mind. The sun low and amber, the air full of scattered light, the blue of day slowly yielding to the warmer tones of evening. There's no hurry. The sky takes its time with this, and so can you. The sky at sunset doesn't change all at once. It's not a switch that flips. It's a gradual, patient unfolding, more like a long exhale than a sudden change of scene. And when you begin to understand the mechanics of it, you start to notice the layers. Think about the sky during the last hour of daylight. If you were to look at it carefully, or simply lie back and let your gaze soften across it, you'd notice that it isn't one color. It's a whole gradation, a series of zones, each one slightly different from the next, stacked gently one above the other, like the colors of a very quiet painting. Directly around the sun, nearest the horizon, the light is often at its warmest, the deep amber and orange, sometimes even a red so soft it looks like the inside of a closed eye, pressed gently against a lamp. This is where the sunlight is entering the atmosphere at the lowest angle, traveling the longest path. And so this is where the filtering is most complete, where almost all the shortwave blue light has been scattered away. Then, as your gaze moves upward from the horizon, the colors gradually shift. Orange softens into yellow. Yellow becomes a pale gold, and higher still, the gold gives way to a thin, delicate green, not always visible, but sometimes on very clear evenings, real and present, a ribbon of green light between the gold below and the blue above. Scientists call this the green band, and it exists because the wavelengths of green light fall between red and blue, long enough to make it through the atmosphere, but short enough to be scattered more than the oranges and reds, creating that thin stripe of cooler color in the gradient. And above the green, if you keep looking up, the sky becomes a pale and luminous blue-gray, and then a deeper blue, and then, almost at the zenith, the point directly overhead, the blue of full day may still be lingering, slow to give way, because up there the atmosphere is thinner and the angle of scattering is still high. This gradation of color from the warm tones of the horizon to the cool tones overhead happens because you're essentially seeing different thicknesses of atmosphere all at once. Your gaze toward the horizon passes through the most air. Your gaze toward the top of the sky passes through the least. Every angle in between represents a different distance, a different amount of scattering, a different balance of the colors that remain. The sky is a spectrum, just like Newton's prism. It separates light by angle rather than by glass, but the principle is the same. Warm colors low, where the most scattering has occurred. Cool colors high, where less has. And in between, the whole gentle range of everything that light can be. On some evenings, when the air is particularly clear, after rain perhaps, or in places far from cities where the air carries fewer particles, this gradation becomes especially vivid. The colors are richer, more distinct. The transition from orange to gold to pale green to blue seems almost deliberate, almost arranged, as if the sky spent the whole afternoon preparing for it. And, in a sense, it did, because the sunset you see on any given evening is shaped by the whole day that preceded it, by the air that moved through your part of the world since morning, by the moisture that gathered or dispersed, by the dust that settled or was stirred. The sky is always keeping its own slow record of the atmosphere, and the sunset is where that record becomes visible. There is something deeply peaceful about that idea, that the colors of evening are the sky's quiet accounting of the day, not in words, not in numbers, but in light. If you're enjoying the story, don't forget to check out the playlist on the Sleepy Science channel. There are more stories just like this one waiting for you, all of them slow and soft and ready whenever you need them. Now, let's talk for a moment about something that makes sunsets even more varied, even more endlessly different from one another: clouds. A sunset without clouds is beautiful, but a sunset with clouds is something else. Because clouds do something extraordinary with the light of late afternoon. They catch it, hold it, reflect it back in ways that no other surface in the sky can quite manage. A cloud is made of water droplets or ice crystals floating in the air. Each tiny droplet acts like a very small mirror, very small lens. When warm evening light, that orange and red light that has already traveled through 100 miles of air, strikes a cloud, the cloud doesn't just absorb it or scatter it the way air molecules do. It reflects it. The whole surface of a cloud can glow with the color of the light that hits it, the way a white piece of cloth glows if you hold a colored lamp close to it. This is why sunset clouds can appear in such vivid, saturated color. The cloud itself has no particular color. It's made of water, which is transparent, and its droplets scatter all colors equally, making it appear white or gray in ordinary daylight. But flood that cloud with amber light, with rose light, with the deep, warm palette of late afternoon, and it becomes a canvas. It takes on whatever color falls upon it and gives it back to you at full intensity. High clouds catch the color earliest because they're higher in the sky and the low sunlight can reach them first. Thin, wispy cirrus clouds made of ice crystals spread across the upper atmosphere in feathery threads can begin to glow golden and pink while the sky below them is still fairly blue. It looks sometimes as if someone took a brush and painted gentle strokes of warm color on an otherwise ordinary afternoon sky. These high clouds are often found at altitudes of 30,000 feet or more, higher than most weather, higher than where most aircraft cruise. Up there, the air is very cold and very thin, and the ice crystals that form can arrange themselves into beautiful geometric patterns, creating clouds that refract light in addition to reflecting it, sometimes producing halos and arcs and other optical wonders. But even without special optical effects, those high clouds at sunset have a quality to them that is hard to name, but easy to feel. They catch light early and lose it late. When the sun has already dipped below your horizon and the lower sky has gone gray and quiet, the high clouds may still be glowing, lit by a sun that is set for you, but not yet for them, because they're high enough that the Earth's curve hasn't blocked the sun from their perspective. Breathe slowly. There's no hurry. This phenomenon, that high clouds can glow after the sun has set, is one of the gentler surprises of the evening sky. You've probably seen it without quite knowing what you were seeing. That moment when the sun has gone and the world is settling into its evening grayness, and then you look up and there, still alight, are those thin, high clouds, pale gold or faintly rose, carrying the last warmth of the day a little longer. They're like the last notes of a song after the music has stopped, Let's move now from the clouds toward the horizon, toward that specific place where the sky and the earth seem to meet, where so much of the most beautiful sunset color lives. The horizon at sunset is not a fixed place. It moves as you move. If you're standing in a valley, your horizon is close. The hills or trees that ring you around define its edge. If you're standing on a high mountain, your horizon is far away, tens or even hundreds of miles distant, the curve of the earth itself beginning to be apparent. If you're standing at the edge of the sea, your horizon is the cleanest and most precise it can ever be. A single, straight, perfectly level line where water meets sky, unbroken and serene. Each of these horizons gives you a different sunset, not just a different view, but genuinely different colors, different timing, different quality of light. Because the distance your horizon represents is the distance the last sunlight has to travel through the lower atmosphere to reach you. At sea, with a distant and unobstructed horizon, you might see the full, unfiltered drama of the color. The sun descends as a perfect disk, growing larger as it approaches the horizon, or rather, appearing larger because the atmosphere acts like a lens near the horizon, bending light and making the sun seem bigger than it is at noon. As it drops lower, it can turn from pale yellow to gold, to deep amber, to red, each stage happening slowly, the colors intensifying like a breath held a little longer than usual. And then, in the last seconds before it touches the horizon, if the air is exceptionally clear, if the conditions are just right, something remarkable can happen. For just a moment, for just the briefest flash, the very top of the setting sun can turn vivid green. Not amber, not yellow. Green. A clear, pure, startling green. Visible for perhaps 1 or 2 seconds before the sun disappears completely. This is the green flash. It's real, and it's rare, and it's caused by the same atmospheric optics that produce all the other colors of the sunset, taken to their extreme. The atmosphere bends different wavelengths of light by different amounts, and for a brief moment, as the last sliver of sun crosses the horizon, the green wavelengths, still present, still being bent upward by the atmosphere even as the sun itself vanishes, become momentarily visible above the disappearing red disk. People have searched for the green flash for centuries. Sailors, scientists, poets. It was once thought to be a legend, a shared illusion, a trick of expectant eyes. But it's been photographed, documented, studied. It's real. It happens at sea most commonly, where the horizon is cleanest and the air clearest. It lasts perhaps 2 seconds. And for those 2 seconds, the sky does something it does nowhere else. It gives you a color that doesn't belong to any other moment of the day. Isn't that something to carry into sleep? The thought that somewhere right now, someone is standing at the edge of the sea, watching the sun go down, and for 2 seconds, 2 slow heartbeats, the sky turns green. The atmosphere bends light in other ways too, near the horizon. Because air density increases the lower you go. Light traveling at a shallow angle through the lower atmosphere is constantly being bent, constantly being refracted, following a slightly curved path rather than the straight line it would travel through empty space. This means that when you see the sun touching the horizon, it has actually already set. Geometrically speaking, it's already below the edge of the earth. You're seeing it because the atmosphere has bent its light upward toward your eyes, keeping the image of the sun visible even after the sun itself has passed below. the sun you're watching set is already gone. That's a thought that could disturb you, perhaps, or it could delight you, the way a good and peaceful thought should. The image lingering after the thing itself has passed, like the warmth that stays in a room after a fire has gone out, like the way you can still feel the sun on your skin after you've come inside. There's a name for this effect: the extra minutes of sunlight you receive each day. The minutes when the sun appears above the horizon but has geometrically already set are called atmospheric refraction. They add roughly a full extra minute of sunlight to your day, morning and evening combined. Every day of your life, the atmosphere has been giving you a small and silent gift of extra light, bending the sun back into view just a little longer than physics would otherwise allow. Please, if this is the kind of thing that helps you rest, share it with someone who might need a quiet night. And don't forget to like the video so the channel can keep growing and keep making these stories for you. Let's stay with the horizon a little longer, because there's more there than just the sun. On the opposite side of the sky from a setting sun, if you were to turn completely around and face east at sunset, you would see something that many people never notice, because everyone is looking west. But the eastern sky at sunset has its own quiet wonder. Low on the eastern horizon, as the sun sets in the west, a shadow rises, a deep blue-gray band, soft at its upper edge, climbing slowly up from the ground into the sky. This shadow is the shadow of the Earth itself, the shadow the planet casts into its own atmosphere as the sun descends. It's called the Earth's shadow, or sometimes the anti-twilight arch, and it is exactly what it sounds like. As the sun goes down in the west, the night side of the planet, the side turning away from the sun, begins to shadow the atmosphere above it, and the leading edge of that shadow, the boundary between the lit atmosphere and the darkening one, rises visibly from the eastern horizon. It climbs as the sun sets. It's the edge of night, visible rising into the sky. Just above that gray-blue band, above the shadow of the Earth, there is sometimes a strip of soft pink or rose light. This is called the belt of Venus, and it exists because the atmosphere just above the shadow line is still being lit by the setting sun's warm, reddened light, catching that amber rose glow and glowing with it, hovering above the shadow like a gentle invitation into the night. The belt of Venus, the shadow of the Earth, the green flash, all of them part of the same sunset, the same physics, the same slow daily miracle of light and air. Breathe in and out. Let the eastern sky rise behind your closed eyes. That soft blue-gray shadow, that ribbon of rose above it, the stars not yet visible, but coming, always coming. Now, let's think about color itself for a moment, about what it means to say that the sky is orange or rose or violet, because color is not a thing that exists out in the world independently of you. Color is something that happens inside you. Light reaches your eye. It passes through the lens, falls on the retina, that thin, curved surface at the back of your eye that is covered with millions of tiny, light-sensitive cells. Some of these cells respond to bright light and give you the basic sense of light and dark, but others, the cells called cones, respond to specific ranges of wavelength, and it's through them that you perceive color. There are 3 types of cone cells in a typical human eye. One type responds most strongly to long-wave light, the red end of the spectrum. One responds to medium-wave light, the green part. And one responds to short-wave light, the blue-violet end. They work together, combining their signals, and your brain interprets those combinations as the full range of colors you experience. Orange, for instance, is what your brain creates when your long-wave red cones are strongly activated and your medium-wave green cones are moderately activated, while your short-wave blue cones are barely responding. There is no orange particle in the air, no orange photon. Orange is what you experience when a particular mixture of wavelengths reaches your eyes. This is why colors can look different in different lighting. Why something that looked one color in daylight looks subtly different indoors, or in candlelight, or under the gray light of an overcast afternoon. The object hasn't changed, the light has. And so, the mixture of wavelengths reaching your eyes has changed. And so, the color your brain creates, the color you see, is different. At sunset, the atmosphere has done its filtering. The blue and violet light has been scattered. What remains has a different mixture, heavier on red, orange, and yellow. And so, your eyes receive that mixture, your cones respond to it, and your brain creates the experience of a warm, golden, amber sky. The sunset is not out there in the sky. The sunset is in you. That's not meant to diminish it. If anything, it makes it more intimate, more personal. The warm colors of evening are something your nervous system creates in response to the light that the sky has prepared. You and the sky making something together every evening without any particular effort from either of you. Just as breathing doesn't require effort, it simply happens. And the colors of sunset simply happen. And you, lying somewhere quiet and comfortable, simply notice them, or simply let them be a soft background to the thought of sleep. The sensitivity of your eyes to color changes somewhat at low light levels. As the sky darkens toward dusk, your cone cells, which require a certain minimum of light to work well, begin to hand over the task to the rod cells, the simpler light-dark receptors. And rod cells don't distinguish color the way cones do. They're better at detecting motion and shape in dim light. And so, as night falls, the colors of the world gradually drain away, growing gray and cool, until by full dark, you're seeing primarily in shades without names. The gray of night, the blue-black of shadow, the silver of anything that catches a stray photon. This shift from cone vision to rod vision happens slowly through the twilight. It's why dusk has that particular quality of fading color, why the sunset gradually loses its warmth and becomes something quieter, more monochrome, more like the world seen through half-closed eyes. And that's perhaps the most appropriate way to receive it, through half-closed eyes, letting the colors soften, letting the distinction between things blur a little, the way it does when you're almost asleep. That in-between state where the world is still there, but you're beginning to let it go. If you'd like to come back to this story another night, or share it with a friend who could use a gentle rest, you'll find it saved in the Sleepy Science Channel playlist, along with other stories about oceans, forests, stars, and rain. Now, let's talk about what happens to the light after the sun has set. Because the sunset doesn't end the moment the sun disappears below the horizon. It continues, and in continuing, it becomes something else. It becomes twilight. Twilight is the time between day and night, the period after sunset or before sunrise, when the sky is neither fully lit nor fully dark, but somewhere in a gentle between. It's the longest gentle thing the atmosphere does, There are actually 3 distinct phases of twilight, each one a little dimmer and a little more hushed than the last. Scientists named them carefully, but the names themselves are almost beautiful. Civil twilight, nautical twilight, and astronomical twilight. 3 stages of letting go. Civil twilight is the brightest phase. It begins at sunset, the moment the sun disappears below the horizon, and it continues until the sun is 6 degrees below the horizon. During civil twilight, the sky is still bright enough to read outdoors or to go about most activities without artificial light. The horizon is still clearly defined. The sky has color, often the most vivid color of the whole sunset sequence, because the atmosphere is still being lit from below by a sun just out of view, and that low, oblique light still has its full warmth. This is when you get the pink and violet and lavender colors that often bloom in the sky after the sun itself has gone. The sun has set, but its light is still reaching the upper atmosphere, and the upper atmosphere is still scattering it, and the colors that reach you are softer now, more filtered, shifted even further from blue toward the gentle, warm, cool end of the spectrum. Rose, mauve, the palest gold fading into silver. The second phase, nautical twilight, begins when the sun is 6 degrees below the horizon and continues until it's 12 degrees down. It's called nautical because historically, this was the period when sailors could navigate by both the horizon and the stars simultaneously. The horizon is still faintly visible, and the brightest stars and planets have appeared, but the sky hasn't yet gone fully dark. During nautical twilight, the colors have mostly drained from the sky. What remains is a deepening blue-gray, growing richer and darker from the horizon upward. The horizon itself is still a shade lighter than the sky above it, still carrying the faint memory of the sun, but the stars are becoming visible, one by one, appearing not all at once but gradually, as if the sky were slowly remembering them. And then, finally, astronomical twilight, from 12 to 18 degrees below the horizon. This is the last whisper of scattered light before true dark. During this phase, only the faintest and most sensitive equipment can detect any brightening in the sky from the sun. To the naked eye, it looks like night. But technically, somewhere in the atmosphere high above, a few photons are still arriving from the sun, scattered so many times they've lost almost all their energy, trickling down through miles of air to arrive at the ground as something barely more than an idea of light. After astronomical twilight ends, it's night, true night, and the sky, finally dark, opens up to the stars. But here's a thing that connects the story of sunsets to the story of the night sky. The same scattering that creates the colors of sunset, the scattering that sends short wavelengths off in all directions, also affects how we see the stars. From within an atmosphere full of particles and molecules, starlight is slightly scattered, slightly blurred. The stars don't twinkle because they're doing anything special. They twinkle because their light passes through miles of turbulent air, each little pocket of turbulence bending the light slightly this way and that, so what reaches your eye flickers and shifts. From space, from above the atmosphere, stars don't twinkle at all. They're steady points of cold, clear light. The twinkling is the atmosphere's signature, its reminder that you're seeing everything through a layer of living air. Just as the colors of sunset are the atmosphere's signature, just as the blue of the daytime sky is, the atmosphere is always present, always shaping what you see, always filtering and bending and scattering. It's the medium through which you experience the sky, and it's the medium through which the sky experiences you. Breathe. Let the three phases of twilight settle over you like layers of a soft blanket, civil, nautical, astronomical. Each one quieter than the last, each one a little darker, a little more still, until the night is complete and the world is resting. Let's go back even further and think about where all of this begins, at the sun itself. The sun is very far away. This is a fact so often stated that it can stop meaning anything at all. So let's try to feel it differently. The sun is, on average, about 93 million miles from the Earth. Light travels at roughly 186,000 miles per second. That means the light that makes your sunset, the light that is, right now, scattering through the atmosphere and creating colors on the horizon, left the sun approximately 8 minutes ago. 8 minutes ago, that light was inside the sun, or rather, it was just emerging from the sun, because the journey to the surface of the sun from the interior takes far longer than the journey across space. Deep inside the sun, where the nuclear reactions happen that produce all that light. A single photon of light might take thousands or even tens of thousands of years to work its way outward through the dense plasma of the solar interior, bumping, scattering, being absorbed and re-emitted, slowly making its way toward the surface. Thousands of years of wandering inside the sun, and then 8 minutes of open space, and then a few seconds of atmosphere, and then it reaches your eye and becomes the color of an evening sky. The light that is making your sunset tonight might have begun its interior journey when your ancestors were building their first cities, or painting the walls of caves, or crossing ice bridges between continents. That's how long it was inside the sun before it finally broke free and began its short sprint across space to you. Isn't it a soft and enormous thought to carry into sleep, that the warm color on the horizon has such an ancient origin and such an immediate presence? The surface of the sun, the layer we see, called the photosphere, is a roiling, constantly moving sea of plasma glowing at a temperature of about 10,000 degrees Fahrenheit. It doesn't burn like a fire. There's nothing to feed a fire there. It glows like an ember, like any very hot thing glows, emitting light across a range of wavelengths simply because of its temperature. The color of a star is determined by its temperature. The sun is on the yellower side of the color range, though in space, without the atmosphere, it would appear pure white. The sky makes it yellow. The atmosphere at low angles makes it orange and red. The color of the sun is, in part, a gift of the air you breathe. Cooler stars than our sun glow red, or a deep orange red. Hotter stars glow blue-white, fierce and brilliant. Our sun, in between, glows with a warmth that life on Earth has spent billions of years adjusting to, so that the light that most feels like itself, the light of noon, or the golden light of a late afternoon, is the light your eyes evolve to see best, the light that most feels like home. There's a kind of deep comfort in that you are built for this particular light, that your eyes, your brain, your sense of beauty, all of them tuned over an unimaginably long time to the specific warmth of this specific star. When you look at a sunset and feel something, some warmth, some brightness, some settling sensation, some part of that might be recognition, the oldest recognition, life looking at the light it grew up in. If you haven't yet liked this video, A small tap on the like button helps the channel find its way to more people who are looking for a peaceful night. It means a lot. Now, let's come back to the atmosphere, because the atmosphere doesn't just scatter light. It also contains things. And what it contains on any given day changes the sunset you see. Clean air scatters light in a very specific and predictable way. The blue scatters most, the red scatters least, and the sunsets are beautiful but relatively restrained. Warm oranges and golds, clear gradations, the colors vivid but not overwhelming. But the atmosphere is not always clean. It contains at any moment a mixture of things beyond just nitrogen and oxygen molecules. Water vapor, dust, pollen, salt crystals carried up from the sea, smoke from fires, and occasionally something much more dramatic, the fine ash and sulfur particles ejected high into the atmosphere by volcanic eruptions. These additional particles change the sunset, not always, and not always in simple ways, but consistently, and often beautifully. Dust carried up from deserts. The Sahara in Africa, for instance, regularly sends plumes of fine reddish dust thousands of miles across the Atlantic, all the way to the Americas, can make sunsets more vivid. The dust particles are larger than air molecules, and they scatter a broader range of wavelengths, adding a richness and depth to the colors of evening. Sunsets during periods of high Saharan dust tend to be more golden, more layered, their colors lingering longer after the sun is set. After large wildfires, the smoke that rises into the atmosphere can have a similar effect. Smoke particles like dust scatter the shorter wavelengths more efficiently and let the reds and oranges dominate. In the months following major fires, people hundreds or even thousands of miles away may notice their sunsets have become more vivid, a side effect of all that smoke suspended high in the air, doing to the light what the atmosphere always does, but more intensely. And then there are volcanoes. When a large volcano erupts explosively, it can send ash and sulfur dioxide gas into the stratosphere, the layer of atmosphere above the weather, above the clouds, above most of what we think of as the air. In the stratosphere, these particles can spread around the entire globe within weeks, carried by winds at high altitudes. And there they stay, slowly settling for months or even years. What happens to sunsets in the aftermath of a major volcanic eruption is one of the most dramatic things the sky can do. The particles in the stratosphere scatter and filter the sunlight even more than usual, removing the blue light even more completely, leaving sunsets of extraordinary richness and color. Not just orange and red, but sometimes purple, sometimes crimson, sometimes a color that seems to have no name, a color that painters have tried to capture for centuries. After the eruption of Krakatoa in 1883, people around the world reported sunsets of unusual and sometimes alarming beauty for more than a year. The sky turned red and purple and green. Artists documented it. Scientists studied it. The atmosphere had become, briefly, a more vivid instrument, playing the same notes it always plays, but with greater intensity. There's something wonderful about the idea that catastrophic events far away can produce beauty in the sky above you. Not something to seek out, not something to celebrate, but something to notice. If you happen to see a sunset that seems richer than usual, more layered, more impossibly colored, it might be the echo of something that happened months ago on another continent, working its way through the atmosphere to reach you. Let your breath slow. Think of the atmosphere as a living thing, carrying particles and memories from every corner of the world, mixing them, filtering them, turning them into light. Dust from the Sahara, smoke from forests, sulfur from volcanoes, salt from the sea. All of it suspended in the air above you, all of it shaping the sky you see. All of it part of the same slow system. The world breathing, the atmosphere thinking, the colors of evening constantly being invented. Water in the atmosphere does something different from dust and ash. Water is transparent. Water droplets, when they're small enough, don't block light so much as bend it, redirect it, create new optical phenomena that have their own names and their own particular beauty. You know about rainbows. Of course you do. A rainbow is what happens when sunlight enters a raindrop, bends at the surface, reflects off the inside of the drop, and bends again as it exits, each color bending by a slightly different angle, so the colors emerge at slightly different positions in the sky, separated into that familiar arc, the red on the outside, the violet on the inside, and all the other colors in between. But you might not know about the fainter rainbow that sometimes appears just outside the main one. This is called the secondary rainbow, and it forms when light reflects twice inside each raindrop instead of once. The extra reflection reverses the order of the colors. Red on the inside now, violet on the outside. And between the main rainbow and the secondary one, there's a band of darker sky called Alexander's Band, a dark space that exists because light is being sent both inward to the primary bow and outward to the secondary bow, leaving a gap in between that receives less light than the surrounding sky. Alexander's Band was described by Alexander of Aphrodisias in the 3rd century CE. He noticed the dark space and wondered about it. It would take many more centuries before anyone understood why it was there. But it was there all along, patient, waiting to be understood. Water vapor, water in its invisible gaseous form, also creates something called a halo around the sun or moon. When light passes through ice crystals in thin, high clouds, those hexagonal crystals refract the light at a specific angle, exactly 22 degrees, creating a ring of light that appears 22 degrees away from the sun or moon in all directions. The halo appears as a faint circle, often with a slightly reddish inner edge and bluish outer edge, sometimes with bright spots at specific positions around it called sundogs or parhelions. Sundogs appear on either side of the sun, level with it on the horizon, at a position roughly 22 degrees to the left and right. They look like small, bright, rainbow-colored patches, miniature suns flanking the real one. They're most visible when the sun is low in the sky, which makes them a feature of the same morning and evening hours when the great colors of sunrise and sunset are happening. Sometimes you can see them through the sunset colors, adding a further layer of optical wonder to an already remarkable sky. These effects, halos, sundogs, arcs, are all caused by ice crystals in the upper atmosphere, and the specific angle at which those crystals are tilted determines which effects appear. The crystals are hexagonal, and they tend to fall with their flat faces horizontal, like tiny dinner plates sinking slowly through the air. When they're aligned this way, the light they refract creates different patterns than when they're randomly oriented. The atmosphere is full of structure we can't see, wind patterns, pressure systems, temperature gradients, all invisible, all shaping the world. But occasionally, in the right lighting conditions, some of that invisible structure becomes visible. A halo appears. A sundog lights up beside the setting sun. A rainbow arcs over the eastern horizon, while the west is still orange from the last of the light. In those moments, you're seeing the shape of the air. Let that be a restful thought, that the beauty in the sky is not separate from the world's workings. It is the world's workings made visible. The atmosphere doing what it always does, but doing it in a way that your eyes can catch if you're looking. Or even if you're not, even if your eyes are soft and half closed, even if you're almost asleep. The sky is doing all of this right now, above wherever you are. The light scattering, the colors forming, the ice crystals tilting, the atmosphere breathing. You don't have to do anything to receive it. You can just rest. Let's take a slower turn now and think about the colors that come after the sunset. The colors of deep twilight and early night. The colors that belong to that threshold between day and dark. After the warm colors of the sunset have faded, after the orange and gold and rose have drained from the western sky, what remains is a blue, but not the ordinary blue of daytime. Something different, deeper, quieter, more interior. This is called the blue hour. It's a real phenomenon, recognized by photographers and painters for centuries, though named formally only in recent times. It occurs in the period of civil twilight after sunset or before sunrise, when the light source for the sky is not the sun itself, but the sky's own residual glow. The atmosphere still lit faintly from below, still scattering the last traces of sunlight, but scattering mostly the cooler wavelengths now. During the blue hour, the sky takes on a quality of light that is very difficult to describe, but immediately recognizable when you see it. It's a rich, saturated, luminous blue. Not the pale daytime blue, but something deeper, more like the color of deep water, or the inside of a mussel shell. It's a blue that seems to glow from within, that lights the world from all directions equally, with no strong shadows, creating a quality of light that painters have always found to be the most truthful, the most interior. The blue hour light is unusual because it comes from the whole sky, simultaneously, not from a single point source like the sun. During daylight, shadows are strong because light comes primarily from one direction. During the blue hour, the sky itself is the light source, a vast dome of faint, even illumination. Shadows are soft or absent. Edges lose their definition. The world looks in this light like something seen through closed eyes, present but softened. It lasts perhaps 20 or 30 minutes, depending on the season and your latitude. And then even that fades, and the stars come through, and the sky is no longer a color at all. There's a reason so many human traditions have associated twilight with a kind of in-between, neither one thing nor another, the threshold between the known and the unknown. In the blue hour, the world seems to pause. The day is done, but the night hasn't fully arrived. Everything is still, suspended, quiet. It's a good time to be lying down, a good time to let the thoughts of the day begin to drift. If this is helping you relax, you're in exactly the right place. And there are more stories like this one in the Sleepy Science Channel playlist waiting for you tonight, or any night you need them. Now, let's think about the sky at the very different latitudes of the Earth, because the sunset you see depends very much on where in the world you are. Near the equator, the sun sets quickly and steeply. Because the sun moves nearly perpendicular to the horizon in equatorial regions, it drops below the horizon fast. The sunset can be over in just a few minutes. The twilight is brief. Within half an hour of the sun going down, it's dark. Equatorial sunsets can be spectacular in their intensity, but they're swift. You have to be paying attention. At higher latitudes, further from the equator toward the poles, the angle changes. The sun moves across the sky at a shallower angle, approaching the horizon obliquely, taking its time to set. This means the sun spends longer near the horizon, and all the effects that happen near the horizon, the scattering, the warming of colors, the filtering, happen for longer. Sunsets at high latitudes can last for an hour or more, the colors changing slowly, never quite reaching their full intensity, but spreading their warmth across a long, unhurried evening. In the extreme north and south, above the Arctic and Antarctic circles, something even more remarkable happens in the summer, the midnight sun. Because of the tilt of the Earth's axis in midsummer at these extreme latitudes, the sun never quite sets. It circles the horizon, dipping toward it, but never crossing it. It touches the north or south point of the compass, and then lifts again, staying above the horizon for days or weeks at a time. The colors of that prolonged near sunset are unlike anything at lower latitudes. The sun remains permanently in the position that produces the most vivid, warm light, low, long-wave light, filtered through maximum atmosphere, always golden, always amber. The sky stays in the colors of permanent twilight. The world glows continuously with the light of an endless evening. And in winter at those same latitudes, the opposite, weeks without sunrise, a long dark that has its own beauty, its own stillness, its own quality of light, from the aurora and the stars. But that is another story. Let's think about the sky in a different way now. Not through physics, but through something softer, through the way it lives inside us. Every culture that has ever existed on this earth has watched the sky. Every civilization has had words for the colors of dawn and dusk, has had stories about what those colors mean, has found in the daily drama of light some kind of message or comfort or wonder. The ancient Egyptians associated the red of the setting sun with the sun god Ra, beginning his journey through the underworld, where he would travel all night before being reborn at dawn. The sunset was not an ending, but a transition, a journey beginning, not concluding. The red of the sky was the color of that passage. In ancient Greek and Roman tradition, the rosy fingers of dawn, the phrase comes from Homer, described the pinkish light of the early sky in terms of a goddess reaching down to open the gates of day. The Japanese word for the faint light of dawn, akebono, literally means breaking bright, a word with a quality of gentleness to it, of something opening carefully. There's a Scandinavian folk tradition that says a red sky at night means fair weather tomorrow. Red sky at night, shepherd's delight. There's a corresponding warning about a red sky in the morning. These sayings are not just superstition. They contain a kernel of meteorological truth. In the mid-latitudes of the northern hemisphere, weather generally moves from west to east. A red sky at sunset means the western air is dry and clear, and since weather comes from the west, that clear air may be on its way toward you. A red sky in the morning means the clear air has already passed east, and wetter, stormier weather may be coming from the west behind it. Old sailors and shepherds, watching the sky with careful eyes over generations, learned to read these patterns. They encoded their observations in rhyme so they could be remembered and passed on. They were doing meteorology before the word existed. And in Japan, there's a concept called komorebi, a single word for the way sunlight filters through leaves, creating patterns of light and shadow. There's no equivalent single word in English. The Japanese language also has a rich vocabulary for different qualities of light and season. Yuyake means the red glow of the sunset sky. Tasogare means the twilight hour, and it literally means, who is that? The time when the light is too dim to recognize faces and you must call out to identify who is approaching. Who is that? The moment when the world becomes unfamiliar in the best possible way, when the light softens and the faces of things become gentle and unspecific. When you can stop identifying, stop naming, stop categorizing, and just be in the quality of the light. That's the invitation of twilight, to stop recognizing for a while, to rest in the general warmth without needing to name each thing. And that, perhaps, is what we're doing right now. Lying somewhere soft, letting the specifics blur, letting the warmth of all these facts about light and color and sky gather around you like the colors of a very long, very gentle sunset. Not needing to remember any of it, not taking notes, just receiving it. The sky does this every day. It doesn't keep score. It doesn't require your attention. It just does it. The scattering, the filtering, the colors assembling and disassembling. And if you happen to notice, that's wonderful. And if you drift away before it's finished, that's wonderful too. Let's talk about something that happens at the edge of the visible, in those last minutes before a true dark. The point when the sky and the imagination begin to meet. You've probably had the experience of lying somewhere at dusk and watching the sky deepen, watching the blue hours settle in, and then, at some point, noticing, without being able to say exactly when it happened, that the first stars have appeared. You didn't see them arrive. They were simply there, suddenly, without ceremony. This is because the eye adapts to darkness slowly. As the sky darkens, your pupils dilate. They open wider to let in more light. The rod cells in your retina, the ones responsible for low-light vision, also take time to reach their full sensitivity. It takes about 20 minutes for your eyes to become reasonably dark adapted, and up to 40 minutes to reach their full sensitivity. This process is called dark adaptation, and it happens so gradually that you don't notice it. You just find that you can see more than you expected to in the dark. The stars you see first, the ones that seem to appear most suddenly as the sky darkens, are the brightest ones, the planets mostly, and a few especially luminous stars. Venus is often visible long before the sky is fully dark. Jupiter and Saturn, depending on where they are in the sky, may follow. Then, the brightest stars, Sirius, Arcturus, Vega, Capella, begin to emerge. The dimmest stars come last, emerging only once the sky has reached its deepest dark. In places with no artificial light, far from cities, far from towns, a truly dark-adapted eye can see thousands of stars on a clear night. The Milky Way, which in light-polluted places is invisible, becomes in these dark conditions a river of soft luminescence, not a collection of individual points, but a band of blended light from so many distant stars that they blur together into something continuous. The Milky Way is our galaxy. When we look at it, we are looking along the flat plane of a spiral disk of several 100 billion stars, most of them so far away that individually they're invisible, but collectively they add up to a visible glow. We are inside the Milky Way, looking at it from within, the way a person inside a glowing ring would see it as a circle surrounding them. And the light of the Milky Way, the light of those billions of stars, left its sources thousands of years ago. The light reaching your eyes on a dark, clear night has been traveling since before recorded history, before agriculture, before language as we know it. The night sky is full of ancient light, not the metaphorical past, but the literal past, photons that have been traveling through empty space for thousands of years, arriving at your eye right now, right here, in this quiet moment. The universe is very old and very gentle in its distance. It asks nothing of you. It simply continues sending its light. Whether or not anyone is looking, you are looking, or you were before your eyes began to close. And that is enough. That is more than enough. Let the thought of all that ancient light settle over you, soft as anything. Let the sky be large and old and very, very quiet above you. If you've been following along and enjoying the journey, a like on the video or a comment below means a great deal. It helps this small channel keep making stories for everyone who needs a gentle night. Let's come gently back to the atmosphere and think about something that connects the sunset to the world of living things. Because the colors of the sky are not separate from the biology of the earth. Flowers, for instance. The colors of flowers evolved in many cases in response to the vision of the creatures that pollinate them. Bees can see ultraviolet light, wavelengths beyond the violet end of the spectrum, invisible to human eyes. Many flowers that appear simple and single-colored to us are, in ultraviolet light, elaborately patterned, with lines and guides that direct the bee toward the nectar. The flower is advertising in a language the bee can read. This is the same fundamental physics as the colors of the sunset. Light in different wavelengths, eyes sensitive to different ranges, a world of color that is real but shaped by the perceiver. The sunset looks the way it does because your eyes are sensitive to certain wavelengths. A bee's sunset, if it could watch one, would look different. Its shorter wavelength sensitivity would perceive things that your eyes miss. The universe of color available to any creature is defined by the specific sensitivities of that creature's light-detecting equipment. Mantis shrimp, small marine crustaceans with some of the most extraordinary eyes in the animal kingdom, have 16 types of color receptors compared to our 3. For a long time, biologists assumed this meant they could see colors far beyond what humans can perceive, a vast new world of color. But research suggests it may not work that way. They may process color differently, not with the nuanced mixing that our 3-cone system allows, but with a kind of faster, more direct classification. Fewer fine distinctions, perhaps, but quicker responses. A different instrument, playing a different kind of music. Birds, whose vision extends into the ultraviolet, much like bees, may see the feathers of other birds in ways that transform their appearance. A bird that looks simply brown or unremarkable to human eyes may, in ultraviolet light, be dazzlingly patterned, communicating courtship, health, territory in a visual language we can't quite read. The sunset for a bird might include a whole component of ultraviolet color in the sky that we're completely unaware of. The sky at dusk might, for them, carry one more layer of color, a cooler, higher frequency shimmer above and beyond the warm oranges we see. The sky has more stories in it than any one pair of eyes can read, and yet The stories we can read, the stories that fit within our limited but beautiful range of vision, are enough to quiet the mind, enough to slow the breathing, enough to make the complicated simplify itself into something that feels in the right light at the right hour, very much like peace. There are moths that navigate by the stars, keeping a fixed angle to the light of a distant star, to fly in a straight line through the night. There are sea turtles that orient by the Earth's magnetic field, sensing direction in a way that has nothing to do with light at all. There are fish in the deep ocean that live in total darkness and have evolved eyes that are so sensitive they can detect the faintest bioluminescence, the glow of living things, against the absolute black of the deep water. Every creature on this earth has its own relationship with light, and all of them are surrounded by the same atmosphere, the same sky, the same daily passage of the sun, the same physics, the same scattering, the ant on the ground navigating by polarized light from the sky, a property of light that human eyes are almost entirely blind to, but that the ant can detect with its simple compound eyes, using it as a compass. The butterfly, choosing flowers by UV markings invisible to us. The robin, following the magnetic pull of the earth, and perhaps also the stars. All of them in the same sunset. All of them navigating by different instruments. All of them in their small and busy and unhurried ways, part of the same slow turning of the world toward night. The light of the sun reaches the earth, the atmosphere filters it, your eyes receive it, and your mind makes something of it. But what does your mind make exactly? What is the experience of watching a sunset? There's research suggesting that awe, the feeling of being in the presence of something vast and beautiful, has measurable effects on the nervous system. Heart rate slows, breathing deepens and regularizes. The sense of time changes, minutes feel longer, less rushed. The feeling of self, of being a separate, distinct individual with a to-do list and a set of concerns, softens temporarily. You feel for a moment less boundaried, less separate. Scientists sometimes call this a small self-experience, the temporary softening of the boundary between yourself and the world around you. It happens reliably in the presence of things that are much larger than you: mountains, oceans, open sky. And it produces consistently a kind of quiet well-being. Not happiness exactly, and not calm exactly. Something between the two. Something that has the quality of both. Sunsets reliably produce this response, not because they're dangerous or dramatic, but because they're vast. Because the sky is larger than any room, larger than any thought. And when the light in it does something beautiful, the size of the canvas changes what you feel. And perhaps this is one of the most restful things about watching the sky. Not the colors themselves, but the scale. The reminder, arriving gently and without alarm, that the world is larger than your current concern, that the same physics that makes your sunset tonight made the sunset last night, and the one 100 years ago, and the one 1,000 years ago. The same scattering, the same colors, the same blue hour following, the same stars emerging. Your specific concerns are real, and they matter, but they're also small in the best possible way, contained within a world that is endlessly larger than them, endlessly older, endlessly doing what it does, regardless of the contents of your to-do list. This is not nihilism. The idea that nothing matters because the world is large. It's more like the feeling of lying down and letting something support your weight. The world is large, and it has held things far larger than your current worry, and it will continue, and you are part of it, not separate from it. Not a small thing looking at a large thing, but a large thing recognizing itself in another large thing, a piece of the universe looking at the universe, and both of you doing fine, both of you continuing. The sky turning its colors, and you breathing here in your comfortable place, and the world holding you as it always has. Let that be the posture of this moment. Let the sky be large. Let your breathing slow. Let the sunset colors you've been reading about exist somewhere behind your eyes. That warm amber, that rose, that lavender, that deepening blue. And let them be as quiet and as present as breathing. Don't forget, if you want more nights like this one, the full collection of sleepy science stories is waiting for you in the channel playlist. Every topic chosen to be gentle, interesting, and sleep-inducing. There's a particular kind of sunset that doesn't involve the sun at all, or rather, involves the sun only indirectly. It's the afterglow. After the sun has set, after even the warmest colors have faded from the western sky, there is sometimes, not always, but on certain evenings, a second brightening, a return, not as warm as the sunset itself, but unmistakable, the soft red or orange or pink reappearing in the western sky, perhaps 15 or 20 minutes after the sun went down, when you might have expected the sky to be growing uniformly dark. This is the afterglow, also called the second purple light, or the purple light of the Alps, a name that comes from the mountains of Switzerland and Austria, where it was first systematically described, because mountains make it most visible. It appears when high clouds or particles in the upper atmosphere catch the last of the sunlight. Sunlight so oblique that it has traveled through enormous amounts of atmosphere to reach those high particles. And so the scattering that remains is mostly long wave. The result is a soft, dusky red or orange appearing in the sky as if from nowhere after you thought the show was over. The sky often does that, offers you something just as you've decided to stop looking. The green flash, the afterglow, the belt of Venus, the first star. These are the gifts for people who wait a little longer, who lie still a little longer, who don't turn away from the window quite yet. And that's a gentle message to carry, isn't it? That waiting and paying attention and not being in a hurry to declare things finished. These qualities are rewarded quietly by the world. But the world also doesn't punish you for missing it. If you were already asleep when the afterglow appeared, you missed nothing of consequence. The afterglow happened regardless. The sky did its work whether or not anyone was watching. And tomorrow it will do it again. The sun will descend, the light will warm and filter. The atmosphere will scatter what it scatters. The colors will arrive in their sequence: the gold, the orange, the rose, the violet, the blue hour, the stars. The earth will turn, as it has for 4.5 billion years, carrying you and your comfortable place away from the sun and into the soft dark of another night. And perhaps this is the deepest rest available in all this sky watching, the knowledge that the sunset is not a performance that requires your attention. It is not something you owe anything to. It simply happens. The result of the earth spinning, the atmosphere scattering, the light traveling. And it will go on happening long after there is anyone to watch it. There is something tremendously restful about processes that do not require you. The sun rises and sets, whether or not you wake. The seasons turn, whether or not you mark them. The stars wheel overhead, whether or not you go outside to see them. The world's great physical rhythms are entirely independent of you, and yet you are inside them. You are made of the same matter as stars, breathing the same air as every creature that has ever lived on this earth, held by the same gravity that shapes the orbits of planets. You are not separate from any of this. You are, in every literal sense, part of it. And so, we arrive at the end of this long, slow evening together. We've traveled from the surface of the sun, where light was born thousands of years ago, through 93 million miles of empty space, through 100 miles of shifting, breathing atmosphere, through the bending and scattering that creates all color, down, through the gradient of warm and cool tones that paints the horizon every evening, through clouds and dust and volcanic ash and water droplets, through the 3 phases of twilight, through the blue hour, through the emergence of stars, through the eyes of bees and birds and mantis shrimp, antis, through the science of awe and the softening of self, all the way to the afterglow, that quiet gift the sky offers when you wait just a little longer. And here you are, still here, having traveled all that way without moving. The air in the room around you is ordinary air, nitrogen and oxygen, just like the atmosphere that filters the sunset. If light were passing through it at the right angle, it would scatter. If a tiny prism were suspended in it, the white light from your lamp would fan out into colors. The physics that makes sunsets is the same physics that fills the space between you and the ceiling. You are surrounded always by the same material as the sky. You breathe it, it holds you, it carries sound and warmth and the occasional breath of wind through an open window. The atmosphere doesn't stop where the outdoors begin. It comes in through the gaps, fills the rooms, rests in your lungs. You are inside the atmosphere. You have always been inside the atmosphere. You are, in a sense, a feature of the atmosphere, the way a cloud is, or a bird, or a plume of dust from the Sahara carried thousands of miles over the sea. Outside, right now, wherever you are, whether there is darkness or the first gray of morning beginning to form at the edge of the window, the atmosphere is doing its work. Light is being scattered somewhere. A sunset is happening on the other side of the world, or a sunrise, or the clean midday blue over some ocean far to the east. The earth is turning. It doesn't stop. And you can stop. You're allowed to stop. Here, in this room, under your blanket, in this quiet. You don't have to follow the turning. You don't have to track the scattering. You can let the sky be large and let yourself be small, and let the warmth of all this slow wonder collect around you like the colors of the blue hour, deep, saturous, coming from every direction without shadow. Let your breathing go first. Let it slow below the level where you're tracking it. Let it become a background thing, like the sound of rain. Let your body grow heavy in the way that bodies do when they are genuinely safe, genuinely still, genuinely at rest. Let any thought that comes arrive and then drift, the way a cloud passes through a clear sky without changing anything essential about it. The sky is still there. The colors will come again tomorrow. The sun will descend. The light will warm. The short waves will scatter, and the long waves will arrive. And somewhere, even if you're not watching, the horizon will catch fire in the gentlest possible way, orange and amber and rose. And then the blue hour will come, and then the stars one by one, the oldest light there is, arriving after its long journey to find the earth turning quietly, and you somewhere on it, resting. Let's think about something we haven't touched yet. The color of the sky in places where the atmosphere is different. Not different because of dust or smoke or volcanic ash, but different because of where you are in the world and what kind of air surrounds you there. In the high mountains, the Himalayas, the Andes, the Alps, the air is thinner. There are fewer molecules per cubic foot of atmosphere above you, fewer particles to scatter the light. And so, the sky there has a quality unlike the sky at sea level. It's a deeper blue, more saturated, almost violently vivid to someone who has only known the softer, hazier blues of lower altitudes. Mountain climbers often remark on it, that blue that seems too blue, that seems to belong to a different planet. This is exactly the same physics, just with fewer molecules, less scattering overall, but proportionally more of the scattering that does happen concentrated in the shorter wavelengths. The blue comes through more purely because there's simply less of everything else. Less haze, less water vapor, less of the accumulated atmospheric depth that softens and dilutes the color at sea level. And the sunsets at high altitude can be similarly extreme. The colors arrive more suddenly, more intensely, without the gradual preparation of a thick atmosphere warming things slowly. The transition from day to night at altitude can feel more dramatic, faster, crisper. The colors vivid and then gone. At the summit of Mount Everest, nearly 6 miles above sea level, the sky is so dark during the day that the brighter stars and planets become faintly visible even in full daylight. The atmosphere above is so thin that the scattering that normally fills the sky with bright blue light is much reduced, and the dark of space begins to show through. Climbers who have been there describe a daytime sky of a blue so dark it seems almost navy, not quite the black of space, but reaching toward it. And sunsets from above the clouds, from the summit of a tall peak, or from the window of an aircraft at cruising altitude, have a quality that cannot quite be described to someone who has only seen sunsets from the ground. You're looking down at a sea of clouds below you, orange and gold in the low light, and above you, the sky is darkening from blue to violet to a deep purple black where the stars are already appearing. And for a moment, you're suspended between the warm world below and the cold infinite above. And both of them are beautiful, and neither requires anything of you. Just the thought of it is something to carry into sleep. That somewhere right now, someone is at altitude, watching the horizon curve gently at the edge of the world. The clouds below, glowing amber, the sky above, going dark and star-filled, and the air around them thin and cold and perfectly clear. The sky that most people know, the comfortable, sea-level, slightly hazy, warmly scattered sky is just one version of the sky. The sky is a different instrument at different altitudes, playing the same notes but in different octaves. And somewhere in between all those versions is the one you know, the one that was above you every day of your childhood, the one you carry in your memory as the default meaning of sky. There's something gently wonderful about that the sky you know personally, the particular shade of blue it tends to be where you grew up, the specific quality of the evening light in the places that feel most like home. That sky is yours in a way no other sky is. It's calibrated to your memories. It's connected to everything you associate with outside, with weather, with the feeling of a day ending, the personal sky, the one that feels like evening, like home, like the right kind of dark coming. Let that sky form behind your closed eyes now. Not a description of it, but the feeling of it. The feeling of evening in a place that feels like home. Light doesn't only travel from the sun to the earth. Some of it, when it arrives, bounces back. The earth reflects a portion of the sunlight it receives back into space, a quality called albedo, from the Latin word for whiteness. Snow and ice have very high albedo. They reflect most of the light that hits them. Fresh snow reflects up to 90% of incoming sunlight. Dark soil and deep water reflect very little. Deep ocean can absorb more than 90% of the light that touches it. Forests, grasslands, deserts, each has its own albedo, its own particular proportion of light kept and light returned. This reflected light goes somewhere. Some of it escapes into space, but some of it is reabsorbed by the atmosphere or reflected again by clouds back down to the surface, bouncing between the earth and the sky in a long, slow exchange of energy. The moon, as you probably know, shines entirely with reflected sunlight. It has no light of its own, and what makes the moon so gentle to look at, that soft, silver, shadowless quality of moonlight, is exactly this. It's sunlight that has traveled 93 million miles, bounced off the gray rock of the moon, and then traveled another 250,000 miles to reach your eye. It has been traveling for roughly 10 minutes in total and has crossed more than 93 million miles. And it arrives soft enough that you can look at it directly. Moonlight is dim enough, about 400,000 times dimmer than direct sunlight, that it cannot activate your cone cells strongly, which means you see moonlight primarily with your rod cells, the ones that don't distinguish color. This is why moonlit landscapes appear in shades of silver and gray, beautiful and clear in their forms, but drained of the particular warmth of day. But there is color in the moon. Scientifically, moonlight is very slightly bluish because the moon reflects some wavelengths of sunlight more than others, very slightly preferring the cooler end of the spectrum. Your rod cells, which see mostly in gray, don't pick this up at normal light levels. But astrophotographers with long exposures and sensitive sensors can capture the subtle bluish tint of moonlit landscapes. The moon also does something magical to sunsets and twilights when it rises in the east as the sun sets in the west. In the right configuration, you can watch the sun going down in orange and amber behind you and turn around to see the moon rising, pale and round, slightly golden from the same atmospheric filtering that warms the setting sun. For a few minutes, the warm light of sunset can fall on the face of the moon, making it glow with an amber quality before it rises higher and cools to silver. This moment, sun setting, moon rising, both visible, the sky orange in the west and fading to blue in the east, is one of the most complete things the sky offers. The whole daily cycle of light compressed into one view, the whole relationship between the Earth and its star and its satellite, made visible at once. You've probably seen it, or something like it, that moment when you feel like the sky is showing you something deliberately, something composed, as if someone arranged it. Nobody arranged it. It arranges itself every day by the blind and beautiful operation of physics. And somehow that makes it more wonderful, not less. The universe has no intention and yet manages this. The light falls exactly right, and the moon rises exactly there, and the colors align in exactly this way. Not planned, not performed, but arrived at through the steady workings of gravity and light and the turning of a planet. If it pleases you, you might press like on this video before you drift off. It's a small thing, but it keeps the channel going and helps other people find their way here for a quiet night. Let the image settle now. The sun going down behind you, the moon coming up ahead, the sky holding both of them at once, west and east, warm and cool, ending and beginning, and you in the middle of it, neither west nor east, just here, just still, just breathing. Water sees the sunset differently than air does. When sunlight reaches the surface of a lake or the ocean at the end of the day, it doesn't just reflect the colors of the sky above. It takes them and transforms them. A flat, calm lake at sunset becomes a mirror of extraordinary sensitivity, catching every color in the sky above it and spreading it across its surface, shimmering slightly with the motion of the water, so that the still image of the sky becomes a living, breathing version of itself. The way light reflects off water obeys specific rules. At steep angles, when you look almost straight down into the water, you see mostly through the surface, into the depth. The reflection is weak, but at shallow angles, when you look across the surface nearly horizontally, almost all the light is reflected and the water becomes highly reflective. This is why, when you look across a lake toward the sunset, the water near the horizon seems to catch the full color of the sky, while the water near your feet lets you see through to the bottom. This phenomenon, the angle dependence of reflection, is called the Fresnel effect, after the French physicist Augustin Jean Fresnel, who worked it out in the early 19th century. It's the same principle that makes windows look transparent from nearby and reflective from far away. The angle changes everything, so a lake at sunset, seen from its shore, shows you a double sky, the actual sky above, and its mirror image in the water below, two sunsets for the price of one. The water's version is slightly softer, slightly distorted by the gentle motion of the surface, the colors breaking and reassembling with each passing ripple. In Japan, there's a tradition of moon viewing parties, gatherings held in autumn to observe the harvest moon. These gatherings often took place near water, specifically because seeing the moon reflected in a pond or lake was considered part of the experience. Not just the moon in the sky, but the moon in the water, the double presence, the image and its soft reflection. There is something about reflection that the human mind has always found restful and beautiful. Perhaps because the reflected image is similar but not identical. It has all the elements of the original, but softened, reversed, made less certain. It's the world, but with its edges blurred. The sky, but with a shimmer in it. A kind of seeing that feels closer to dreaming than to the sharp clarity of direct vision. Puddles after rain are small mirrors. The surface of a cup of tea can reflect a window. Frost on a glass can scatter light into colors. The world is full of small reflections, small doublings of the sky, small copies of the light that came all that way from the sun to be caught in a puddle on the pavement and then redirected upward toward your passing eye. Every drop of morning dew on a spider's web contains a tiny, complete image of the sky above it. Each dewdrop is a perfect little lens, gathering the light around it and focusing it into a miniature world inside itself. A spider web covered in morning dew is a collection of hundreds of tiny sky images, each one slightly different depending on its position and orientation. A mosaic of small dawns hanging between the grasses. The spider doesn't know this. The web is for catching insects. The dew condensed on it overnight because the web's surface cooled below the temperature at which moisture in the air converts from vapor to liquid. Physics, not aesthetics. And yet, the result is something that stops you in your tracks on a morning walk. If you happen to look down at the right moment, in the right light, the world produces beauty without knowing it's doing so. And you get to notice it if you happen to be there. And that too is enough. That too is a reason for a quiet kind of gratitude as you lie down at the end of a day. The colors of the sunset are also written in the ground beneath you. The same physics that warms the sky, the filtering and scattering of light, also affects the way everything on Earth appears in the evening. The warm, reddened light of late afternoon and sunset falls on every surface, grass, stone, bark, soil, skin, and it changes the way they look. Grass, which in the white light of noon appears a clear and vivid green, shifts in the amber light of late afternoon towards something warmer, more golden. The green is still there. The chlorophyll in the leaves is still absorbing red and blue light and reflecting green. But the light falling on it is now more orange and red. The green reflected from the leaf mixes with the warm ambient light, and the result is something different from ordinary green, something richer. The green of late afternoon has yellow in it, has warmth in a way that the green of noon doesn't. This is part of what makes the light of the golden hour, the hour before sunset, so beloved by photographers and painters. Not only does the light come from a low angle, creating long dramatic shadows that reveal the texture of surfaces, but the light itself has a warmth that shifts all colors slightly toward amber and gold. Skin looks different in it, less clinical, less pale, suffused with a warmth that feels flattering because it feels alive. Stone looks different, less gray, more golden. Water looks different, less blue, more bronze. The world in golden hour light looks, essentially, like itself, but better. Like itself, but more itself. Like the version of itself that remembers being warm. There's a reason campfire light feels the way it does. Firelight is warm spectrum light. It has the same amber red quality as sunset light, the same preponderance of long wave color, and so a face seen by firelight looks the way a face looks in the golden hour. Warm, softened, lit from a low angle with gentle shadows. The associations we have with firelight, safety, warmth, the end of a day, the coming together of people in the dark, are ancient associations. We have been sitting by fires at the end of the day for hundreds of thousands of years, and the sunset light has the same color. It triggers, perhaps, some of the same ancient sense of the day completing, of it being time to gather close, to slow down, to let the dark come, and not be afraid of it. There are records of other apes, chimpanzees, our closest relatives, pausing to watch sunsets, stopping what they're doing and simply looking at the sky as the colors change, not doing anything with the watching, just being present with the colors. We have been doing this for a very long time, before language, before fire perhaps, just creatures with eyes sensitive to the warm end of the spectrum, pausing at the end of the day to receive what the sky was giving. You are in that lineage. This quiet watching, this unhurried receiving of the colors is one of the oldest things there is to do with an evening. And you're doing it right now, behind your closed eyes, letting the colors form and shift. Amber, rose, violet, blue, the patient colors of the end of a day, the same ones your ancestors saw and their ancestors before them, and the ones before language who simply looked and felt something settle. The channel playlist has more of these stories ready for you. Evenings about the ocean, about forests, about rain and rivers and stones. Come back whenever you need to settle. Let's think about what sunsets look like from space. Not from the very high altitude of a mountaintop, but from truly outside the atmosphere. From the vantage point of spacecraft or the International Space Station, where astronauts have had the extraordinary experience of watching the Earth turn through day and night from above. Astronauts aboard the International Space Station orbit the Earth at an altitude of roughly 250 miles, traveling at about 17,500 miles per hour. At that speed, they circle the entire Earth every 90 minutes, which means they experience 16 sunrises and 16 sunsets every single day, 16 times the orange and gold on the limb of the Earth, 16 times the blue fading to black, every 45 minutes from day to night, every 45 minutes from night to day. They have described it, many of them, in interviews and memoirs and letters home, as one of the most beautiful and emotionally affecting things a human being can experience. Not the weightlessness, not the view of continents, not the stars unfiltered by atmosphere, though all of those are remarkable too. The sunsets, the sunrises, the repeated, relentless, gorgeous cycling of the Earth through light and dark, seen from outside. From the station, the atmosphere is visible as a thin, luminous ribbon around the curve of the Earth. It looks fragile from up there. It looks like barely anything. A narrow strip of colored light, blue, fading to violet, fading to black, perhaps only 100 miles thick in the visual impression. Against the size of the Earth, the atmosphere looks like the skin of an apple. And inside that thin skin, all the light scattering happens, all the blue of the daytime sky, all the colors of the sunset, all the weather, the clouds, the rain, the snow, the wind, all the air that has ever been breathed. All of it contained in that thin, luminous, apparently fragile layer. From up there, looking down, the sunset is not something overhead. It's something the Earth is wearing. The colors are a band around the planet, a ring of warmth where the day meets the night, moving slowly across the surface as the Earth turns. The astronauts can see it approaching as they orbit the terminator, the line between day and night, and watch the colors bloom along it as they cross it. Many astronauts have spoken about the feeling this produces, a sense of the smallness and the preciousness of the Earth, a feeling that the thin atmosphere is something to be careful with, something delicate, something that deserves attention. Several have returned from space, permanently changed in how they relate to the planet, more tender toward it, more concerned about it, more aware of how thin and irreplaceable that skin of air is. This shift of perspective has a name, the overview effect, the change in a person's relationship to the Earth and to humanity that comes from seeing the whole planet from outside. It tends to dissolve certain boundaries that feel very solid from the ground. National borders, cultural differences, the sense of separation between one kind of person and another. From 250 miles up, the Earth is one thing, The atmosphere wraps it entirely, making no distinction. The sunset, seen from space, is a global event, not something happening in the West, not something you're either watching or missing, depending on where you're standing. It's a band of color circling the entire planet, following the Terminator as the Earth turns, always present, always moving. The sunset doesn't set, the Earth turns through it. Let that image take the place of any remaining thought. The Earth turning through its band of color, the atmosphere glowing at the edge, fragile and luminous. You, somewhere on that turning surface, resting in the dark half, carried through the night at 1,000 miles per hour by the turning of the world, moving steadily toward your own private dawn. And finally, let's come all the way back down, from space, from altitude, from all the distances we've traveled tonight, all the way back to the ground, to something very small, the same light that creates sunsets, that fills the sky with color, that reaches the eyes of orbiting astronauts. That light also falls on a single blade of grass, on one drop of dew, on the wing of a moth resting on a stone wall in the evening. The wing of that moth is made of thousands of tiny scales, each one thinner than a human hair. The scales overlap like roof tiles, each one a slightly different shape, depending on its position on the wing. And in some moths, those scales are not pigmented. They don't contain color in the way that paint or ink contains color. Instead, they create color the same way the sky does, through the physics of light. The scales have microscopic structures, ridges and layers spaced at distances that match the wavelengths of light. When light enters those structures, some wavelengths reinforce each other and others cancel out. Certain colors are amplified, others are suppressed. The color you see is the color that wins, not because of pigment, but because of structure, because of the way light interacts with matter at the scale of wavelengths. This is called structural color, and it's everywhere in nature once you know to look. The iridescent blue of a morpho butterfly's wings, the green shimmer on the neck of a hummingbird, the sheen on a soap bubble, the color of a peacock's tail feather. None of these colors come from pigments. All of them come from the way light interacts with the carefully structured surfaces at the microscopic level. The sky is structural color on an enormous scale. The blue overhead is the same phenomenon as the blue of a morpho butterfly. Not pigment, but physics. Wavelengths selected by interaction with structure, certain colors reinforced, and others scattered away, the result perceived by an eye as a particular shade of a particular color. The moth on the wall, the butterfly in the afternoon light, the sky above them both. All producing color the same way, all using the same fundamental property of light, its wave-like nature, its tendency to interact with structures whose size is comparable to its wavelength. The world is more unified than it appears. The same principles run through it at every scale, from the microscopic ridges on a moth's wing to the molecule-scale interactions in the upper atmosphere, to the full planetary event of a sunset seen from space. The physics doesn't care about scale. It does the same thing at every level. And you, lying here, breathing here, are also made of structures that interact with light. The protein structures in the lenses of your eyes, the layered membranes of your retinal cells, the particular way the molecules of your skin absorb some wavelengths and reflect others. You are part of the same optical story. Light falls on you, and you interact with it, and some of it passes through you, and some of it is absorbed, and some of it is reflected, and the world sees you in the colors that result. You are, in this sense, also a kind of sky, a surface that light falls on and responds to. A place where physics becomes experience. And right now, in the dark of wherever you are, with your eyes closed and your breathing slow, even that is at rest. The light has stopped falling, the colors have gone quiet. The physics is still happening, of course. It never stops. But your part in it, for now, is simply to receive the dark, to let the rods take over from the cones, to let the world go silver and gray, and then to let even that dissolve into the softer dark of sleep. The atmosphere will keep scattering. The earth will keep turning. Somewhere on the other side of the world, right now, someone is watching a sunrise. The same colors, in reverse order, the same physics, the blue and violet filtering back into the world as the sun rises above their horizon. The same light you watched set is rising for them, amber becoming gold, becoming pale yellow, becoming the ordinary clean blue of a new day. It's always happening, somewhere, always, the sunrise and the sunset both, the planet dressed in its permanent ring of color, turning slowly in the light. And here you are at the center of your own small darkness, warm and held and entirely allowed to sleep. The sky has this. It always has this. You can let it go now. Let everything go. The facts, the colors, the distances, the wavelengths, the history of light. Let it all settle like dust after a long journey. Let it lie quiet in you, not as information, but as something softer, a texture, a warmth, the residue of having spent an evening in the presence of something very large and very beautiful and very, very calm. The Sleepy Science Channel will be here when you come back. The playlist is full, the stories are waiting, but not tonight. Tonight is for sleeping. Close your eyes. Feel the weight of yourself against whatever is beneath you. Feel the air moving in and out, steady, patient, doing its work without you. The sunset is somewhere. The stars are out. And you are exactly where you're supposed to be. Sleep now. Sleep well. The light will come again.